All right. Good morning, mathematicians. I again, I'm still sick. I apologize. I really, yeah, it's really rare for me to miss school this much, but I'm really trying to focus on getting better, and I'm making these videos because I really care about your guys' learning. So hopefully you guys are enjoying these. Sorry, I'm just getting to the correct page here. Let's see. Going all the way to the back of the booklet here. All right. Now, I'm going to walk you guys through your Quiz 1 review, and hopefully this will answer any questions that you guys have, and work through any of the topics that you guys were struggling with, okay? So let me make sure this works. Awesome. Cool. I have my Apple Pencil. I made sure that was charged today, because the other stylus, that was a mess. All right, here we go. We're going to graph the following points here, which I did, and it creates this lovely triangle. Okay. Please, on your quiz, please use a ruler, guys. Okay? That's all I ask. Protractors are there for you guys. Rulers are there for you guys. So if you don't have one, please borrow one. That's all I ask. Okay? So, I mean, by doing this, we answered questions 1 and we answered question 2. Now it says to find the exact length of DO, and that is this line right here. Okay? When you graph, it is very important that you guys label with the letters given to you, so that way you find the correct side length. So this is a direct application of the lesson where we had to create squares, we had to find the area of the squares, and then we had to take the square roots in order to find the side length, and that's exactly what we're doing here, okay? So the first thing, we got to create our square, and we need to use our slope here. It looks like we went up 3 and over 1, 2, 3, 4, 5. So it looks like the slope of DO is 3 over 5. Okay, and the opposite reciprocal slope, right, taking that slope that's perpendicular at -5 over 3, or in this case, I'm going to say 5 over -3, and you'll see in a little bit why. So from O, I'm going to go up 5, 1, 2, 3, 4, 5, and then this -3, I'm going to the left 3, 1, 2, 3, so my point is here. So do you guys see why I put the -3 on the bottom? Or why I put the negative sign with 3 rather than the 5? Because if you were to do -5, you would move in the opposite direction, right? You'd want to move down. I'm going to do the same thing from point D. I'm going to go up 5, 1, 2, 3, 4, 5, and then to the left 3, 1, 2, 3. Okay, I'm going to erase some of my work here so that way it's nice and clean. And here we go. And there's my square. Okay, and remember, you got to split the square. Now that we have the square, you have to split the square into smaller squares and triangles. So maybe something like this. Oops, that's a little too far. There we go. And then find the area of each piece. This is a 1, 2, 3 by 1. 5 times 3 is 15, and half of 15 is 7.5. So all of these are 7.5. I don't have a calculator on me, so I'm going to calculate this really quick. 7.5 times 4, 28, 30. Awesome. All right, so it looks like the total area of this square is going to be 34 square units. All right, but the question's asking for the side length, and it says the exact length. So we're not going to use our calculator here. We're going to take the square root of 34, and we need to double check to see if we can simplify this. If you can simplify, this is what I tell my 6th graders with fractions. If you can simplify, you must. This applies to you guys now with your radicals. Okay, so if you can simplify them, you must. So let's take a look. Can I do anything here? Let's see. I know that 34 is 2 times 17. Well, 17 is prime. 2 is prime. So I can't. So my final answer, side length, is equal to the square root of 34 units. Oh, and then they did ask for the area of dog. We say that the area is 34 square units. How are we doing so far? Are we doing okay? I think you guys are fine. All right, let's keep going. Find the area of a 7-sided irregular figure. Okay, so again, you got 2 strategies. You could either draw the box around, or you could split the shape inside. In this case, I kind of like the box around, just because I can see it. So the box around, let's see, this is a 1, 2, 3, 4, 5. This is a 5 by 5 square. So the area I know I have to subtract from 25. Now let's find the area of every little piece inside. So let's see, this triangle is 2 by 1, so that's a 1. This is 1, 2, 3 by 1, so that's 1.5. This is a 1, 2, 3 by 1, 2. So this is 6 over here. And this is a 1 by 1 square. And then these little triangles are 1/2. I'm just going to say that this entire triangle here, this entire triangle here is 1. So I'm going to add all of these up together. 6 plus 1 plus 1 plus 1, that's 9, plus another 1.5. So that's going to be 10.5. Let's subtract 25 minus 10, 15. 15 minus 0.5 is 14.5. So it looks like the area here is 14.5 square units. Okay. Number 6, this question is wrong because this is a 3-sided figure and not an irregular 4-sided figure. So hopefully, I think you guys kind of figured that out. Again, you have 2 options. You can split the shape into smaller shapes, or you can draw a square around it. I would probably draw square rectangle, I'd probably do the same method here. Okay, but either work. One, and guys, usually one works better than the other. Okay, so my square 1, 2, 3 or my rectangle 4 by 1, 2, 3. It's a 4 by 3. So the area I know is going to be 12 minus the unshaded parts, or the outside of the figure. All right, let's take a look. The triangle on the left side is a 1, 2 by 2. So that has an area of 2. This one here, 1, 2 by 1, 2, 3. That has an area of 3. And this one on the very bottom has an area of, it's a 1, 2, 4 by 1. So that's also an area of 2. So I add these up, which is 7. So it looks like the area is going to be 5 square units. And there we go. All right, find the edge length of a cube. And so 216 represents the volume here, units cubed. And in order to find the edge length, we just got to take the cube root. And this is where you guys memorizing your square roots and cube roots kind of comes into play. If you haven't memorized, then this question is probably really straightforward for you. So let's take a look. I know that 4 cubed is equal to 64. This is still a little bit away. I know 5 cubed is 125. Maybe 6 cubed will be my friend here. I know that 6 squared is 36. If I multiply it by 6 again, 18, there we go. So it looks like the edge length is equal to 6 units. There we go. Find the side length of a square. So we know that the area is equal to 81 square units. To find the side length, all we got to do is take the square root of 81. And again, if you guys memorize your perfect squares, you'll know that the answer is 9 units. Okay, I wanted to walk through maybe like two problems with simplifying square roots. So let me get up a few problems here. 1 second, folks. All right, let's take a look at the square root of, I'm going to create a little divider here. So taking a look at the square root of 125. Now remember, when simplifying, it is probably the easiest thing to do is find a perfect square and multiply it by another number, right? We're trying to split this number underneath your radical into a perfect square and another number. So I know that 25 times 5 gives me 125. Just so happens that I can take the square root of 25, so I could rewrite my expression like this. The square root of 25 is 5, and then that times the square root of 5. So there's my final answer. Let's do one more. I'm going to do the square root of 80. If you can't find a perfect square, that's okay. Let's split it into really any two numbers. I mean, we could even do more numbers if you want. So let's take a look. Say you can't think of it and you know that this is 40 times 2. Well, let's keep going. Let's split 40. You know it's 10 times 4. And then let's keep splitting it more. So you know 10 is 5 times 2. And then you also have this 4 times 2. Okay. Can I combine any of these factors and make them into a perfect square? You might notice that, hey look, I have 2 2's. And I know that 2 times 2 is 4. So I'm going to rewrite it. I'm going to move over here. We have the 5. We have that first 4, so I'm just rewriting this. Then we have the second 4, which comes from the 2 times 2. Now I can rewrite this like this. So I have the square root of 5 times the square root of 4 times another square root of 4. So if I rewrite it again, I have square root of 5 times 2 times 2. 2 times 2 is 4. And then 4 times the square root of 5, we can write like this. And there we go. If you notice that the square root of 80 is equal to square root of 16 times 5, right? Then more power to you. But do you see what I mean? Finding a perfect square and multiplying it by another number to get the number under the radical sign is a lot more direct. It's a lot more straightforward. And you get the same answer. Okay, but if you can't, break it down. Break it down like what I did here on the right side. Okay? All right, you guys. Well, that's it for me. Good luck on your quiz today. Not that you need it. All right, see you in the next lesson.